All right, well, good morning, everyone. Hi, good morning. This is Joe Vidal, Director of Distribution NSP and our major nationals for Hewlett-Packard Enterprise. Glad to be here with the Nexinet folks this morning and everyone else that's connected in. I've got Dan Rocker. Dan, why don't you go ahead and introduce yourself?
Hi, everyone. My name is Dan Rocker. I'm a Mid-Atlantic Channel Compute Solution Architect supporting a Nexinet from Hewlett-Packard Enterprise. Good morning.
I love it. And Dan is actually going to be driving the slides this morning while Dan and I try to do kind of a radio broadcast back and forth to keep it light and informational for you folks this morning. Dan and I have probably collectively been selling and or configuring, designing solutions for Hewlett-Packard and or Compaq Company collectively for probably close to 45 years. Dan, how long have you been with the company, Dan?
I've been with the company 3 years, Joe, so I'm a little newer.
All right, so for the two of us then together, 30 years. Overestimated. All right. Well, real quickly, what we're going to do is we're going to share with you just a real quick high level of HPE's new corporate strategy and then get right into what is our idea and vision for delivering hybrid IT and what are the new solution sets, diving into what is composability and basically the technologies that enable that. So if we could go forward, Dan, we're going to real quickly just highlight the fact that HPE's corporate strategy is really focused on 3 simple pillars, and that is that we believe that the world is going to be hybrid and that HPE and our partners together make hybrid IT simple, delivering traditional data center as well as software-defined infrastructure, and you'll hear from us that our composable solutions and the synergy technologies underneath the composable solutions are really the first 100% software-defined infrastructure, enabling basically and delivering fluid resource pools of, we'll say, compute, storage, and I/O, or flex networking capabilities enable you to compose either compute, compose storage, compose clustering technologies, whatever you need, you compose it, right? You need a little more compute, you compose it. We'll get into how we do that in just a second. And of course, it's really all behind a cloud-native infrastructure enabling customers to finally deliver on the continuous DevOps promise, if you will, or the entire software-defined data center promise. Now, secondly, we believe that there's an explosion going on the edge right now, and we deliver on that intelligent edge. We kind of power the edge or the intelligent edge, and we're going to talk to some of that as well. And that is really a huge play in campus, branch offices, whether that's in healthcare, education, corporate connectivity, or enabling location-aware services in applications that allow our customers to branch off and open up new revenue opportunities. And we'll even talk about a couple of those examples. And that ties in the Internet of Things into back office information and extremely efficient, we'll say, composable infrastructure on the front end that ties those together, aggregates all that together. And then lastly, along with our partners in Nexinet, we can actually make it happen, right? So those 3 pillars are basically that we believe the world is going to be hybrid, there's an explosion going on at the edge, and that we, HPE, and our partner community, along with Nexinet, can make it happen. So Dan, let's move on. And of course, it's really all around Gartner's and IDC's view of what is the ID economy, right? Which is continuous DevOps, continuous change, and radical with different simplification around automation. But we also have to understand that traditional IT isn't going away. So we have to be able to do both while delivering disruptive solutions that allow our customers to deliver disruption within their own markets. And then, of course, delivering on that Internet of Things and explosion of devices. It's okay, Dan. The next slide actually would have been perfect right now. You were reading in my mind. And as we connect both traditional IT along with the new ID economy, enabling cloud-enabled applications, mobile-ready hybrid infrastructure, it finally allows us to deliver on those continuously changing IT demands by our business unit owners. And these are the kinds of things that are driving many business unit owners or business unit heads and leads to swipe their credit cards and enabling applications to burst out to the web or actually to leverage web and Amazon Web Services today, because typically IT can't seem to keep up, can't seem to divvy out those VMs or that additional storage element, allowing the business units to do their development on time and on budget. And now we have an infrastructure that enables you to do both of those and actually beats the cloud pricing model or the cloud economics, as we say, and allowing us to respond rather than react. And of course, our portfolio strategy, as I mentioned, both driving the ID economy via hybrid IT, and that hybrid IT is a mix of traditional with new, as well as completely software defined. So we're enabling that intelligent edge with open-based applications, open API-based applications that leverage simplified code or simplified connectors into everything, and we'll get into what that everything is in just a second. And of course, when we look at storage affinity, we are always asked, and Dan, this is one of those where, please, chime in. We were just with the Nexanet folks in an executive briefing in New York earlier this week, and one of the questions that always comes up is, okay, you guys have a lot of different storage options, so help me map in which storage do I use with which model, right? If I'm using a hyperconverged appliance versus this new Synergy thing, what am I connecting to? So I know, Dan, you did a great job kind of describing that, so I'm going to let you kick in here.
Sure, thanks, Joe. Really, one of the major acquisitions by Hewlett-Packard Enterprise in the past few months, and there's been quite a few, is the acquisition of SimpliVity in the hyperconverged space, giving us some advanced data services that really enrich our hyperconverged 380 solution, that really gives us some advantages not only in the enterprise space, but for your remote office or branch office, right? And those are really for virtual only environments, right? That's why we coined the VM vending machine moniker for our hyperconverged 380 solution. But when you're going for that true flexibility, when you're trying to deploy at cloud speed, whether that's a bare metal virtualized or containerized solution, we really see Synergy being the solution there, being powered by our OneView management solution, and that really enables all of that RESTful API integration that makes that flexibility so easy.
Well said, and now you know why it is that we have Dan on the line. Great job, Dan. Well, let's talk about, so the question is, then why composability, why Synergy, why now? Right, and it gets into moving beyond the capabilities of existing infrastructure, existing rack mount servers, or existing blade technologies, right, and delivering something that's going to be future-proof. Back when HPE brought out BladeSystem, which was back in '06, we designed it in '04, '05, brought it out in '06, and we really designed it to be around for about 5 years through 2011, and it's proven to be a much more long-standing, long capability because of its, well, extreme growth and expansion capability, right? As we brought that out with a 5.4 terabit midplane, we expanded it to 7.2. We added location enhanced services capabilities to be able to map itself within the data center location, basically. And now we're jumping in with a new infrastructure that starts at 16 terabytes a second, and 16 terabits a second, and is going to go on to then to almost a nearly infinite amount of bandwidth because we have made it photonics ready. But we're also delivering a much better TCO story, and what's really impressive, Dan, is that we're delivering basically a lower TCA right off the bat, which is a lower total cost of acquisition, as well as a lower total cost of ownership. And we'll get in there. So Dan, what are some of the other things that you'd say are really important that make this infrastructure and this solution set stand out?
Well, I think one of the major things here, Joe, is the way we've really created this solution to look and feel a lot like a C7000, but we've really made it purpose-built for the software-defined data center. By installing a Synergy solution into your environment, number one, now you can treat that environment as a fluid pool of resources. And by navigating OneView and creating templates for your applications, we can programmatically change the way that you administrate your infrastructure. And that's really the whole design principle behind Synergy and composable infrastructure.
You nailed it, Dan, right? And the really important thing is here, when we look at both the business benefits and then the design principles and the operating benefits from an admin perspective as well as from a business unit owner perspective, everybody gets what they want, right? And who doesn't want to reduce their cost, deploy at cloud-like speed, and simplify operations, as well as being able to deliver more applications simpler with a unified API? So the question is, how do we make this all happen? So let's keep moving forward. And we're going to give you several of different examples, and by the way, we're also going to step through the actual numbers behind these statements on this total cost of ownership kind of high-level summary. And one of the important things is we hear from our customers all the time. Every time we come out with something radically different in the marketplace, I get people telling me, Joe, you know, this is all well and good, but I have no budget for new infrastructure this year. Right, and we've all heard that, right? And I understand, right? Many people don't budget for something new; they budget for simply growth. And finally, we have an infrastructure solution that saves you money in a simple growth model by delivering something new that pays for itself in less than 4 months. So no longer does a customer have to have a new budget for new growth, new training, because A, it uses the same tools, the same automation and management tools, OneView, that we've been using for several years now, right? So there is no learning curve. More importantly, it pays for itself, and in fact, it's one of those that you can't afford not to install it, right? By delivering this simple automated hardware, and more importantly, giving you something that's error-free and checks itself before installing its own firmware updates, right? So even the line of business and IT developers are getting what they want, because it makes it easy for them to request nearly cloud, well, we'll call it cloud simplicity without necessarily the self-services portal, and we can get to that too. So let's keep moving, Dan. All right, so Dan, tell me, what is it that's so new about this ideal integrated system?
Well, with this Synergy platform, really you're able to provision bare metal, virtual, and containerized resources side by side from the same single pane of glass that is HPE OneView, and we're calling that the composer in this Synergy solution. And not only that, from a compute perspective, but we're also able to provision large amounts of direct attached storage, use that same storage perhaps in a software-defined scenario, perhaps using something like Store Virtual VSA or vSAN or some other software-defined storage, or composing out of a Tier 1 SAN like an HPE 3PAR, right? And being able to have that flexibility, so when a new application decision point, we have a new idea, you know, we want to make some changes to our environment, how long does it take? Do we need to procure more infrastructure? How quickly can we stand it up? Right? And Synergy is purpose-built to answer all of those questions as fast as possible.
Well, you know, and you bring up a good point, Dan, because you said that you could basically, what I'm reading behind the line, or between the lines of what you just said, is that you can basically deliver both bare metal and entire solution sets. So I'm going to add in a question here that we get all the time from customers is, so what I'm hearing is, can you deliver hyper-converged appliances via this infrastructure?
I wouldn't necessarily say that. Yeah, so it is a trick question, right? Because by our definition, hyperconverged would be a complete package with server storage, networking, and some kind of slick management added onto it to give you that value add for ease of deployment, ease of scaling, things of that nature. With Synergy, you get all of that and more because of the
That's exactly right.
and the containerized availability as well.
Yeah, that's the key to the trick question that I was asking. But bottom line is that when you say that we can automate the implementation and installation of VSA, and of course we can certainly automate the installation of ESX, right, which would be VMware or Hyper-V for that matter, right, Microsoft Windows Server 2012 and whatnot, you can choose whichever hypervisor you want and then layer on top of it VSA or whatever other software-defined storage you care to install, and then the other application stacks as well even, right? And all of that's automated via OneView and its holistic open API set. And so the answer is basically, yes, you can do that with our templates. You can define then a profile that defines VSA and ESX on multiple nodes, then we basically have a simplified workflow orchestrator built in, which is inside of OneView now, enables you to do all that, and you don't need the separate appliances. You can compose your own appliances at will. All right, so then the question is, what are some of the other benefits? And we've included some of these other marketing benefits in here just so that we can ground ourselves in really what this is all about for our customers, right? That it's future ready, delivering fluid resource pools with, of course, better economics and automated intelligence. So now let's get into what is Synergy as we move on to what is the engine for the IT economy. Dan, tell me about some of these new pieces of the Synergy infrastructure. What makes it up?
Sure. So if you follow around the ring of the outside, you'll find 5 things called out: composable compute, composable storage, a rack scale fabric, a new frame, and the composer. The composer is our software-defined intelligence we're talking about, right? That's going to be one view living on the frame, and that's where we're able to do all of that templating, all of those administrative changes, firmware updates, those kind of scheduled updates. Maybe we have servers out of compliance. We want to add more storage to a template, maybe change the boot order, things of that nature. That's all done in the composer. With
Well,
composable,
absolutely.
yeah, sure.
And well, let's not go too deep because we have different, more
Understood.
slides that go into each of those. The one thing that I really want to make sure that everybody understands from this particular high-level view of everything that goes into the Synergy infrastructure is that composable storage is actually really new, since this isn't just storage that's mapped from one node or one slot to whatever compute node is in the slot next to it. That's the way we did it with Blade System. In Synergy, we actually basically have a 40 drive drawer, of which you can have 4 of them in the actual Synergy frame, and these are all mapped, or can be mapped as local storage. So this is local SAS storage that's really the difference between us and the difference between what we used to do with Blade System, the difference with what Pure has promised versus not delivered, versus what everything else that even looks like a shared infrastructure environment. This is really one of the biggest things that makes it different. And then, of course, our composable fabric. But let's get into what each of these actually delivers. On the next slide, we actually get into where everything resides. So, Dan, I'll turn it back over to you to kind of map around the screen. What is it? Where does it go? Why did we put it there?
Sure. So at first glance, this is going to look and feel a lot like a C7000. One of the first things you might notice is there's actually a smaller number of blade bays in this Synergy 12,000 frame. We call it the 12,000 because there are 12 half-height blade bays. That's because now I can have 24 DIMMs and no processor restrictions on those half-height blades. That is, if I want to go up to the biggest core count and fill it up with 3 terabytes of memory, I can do that. And that flexibility allows you to consolidate more, have larger virtual machine farms in those blades, as well as more flexible environments. Some of the things you might see called out here is the composer and the image streamer, 2 appliances that are built into the frame. As you start scaling in this environment, a lot of those appliance bays will be empty, but those are the 2 main management tools that administrate the infrastructure. And we'll talk about the rest as we go through the presentation as well.
Awesome, Dan. And that's really important to understand that as you add in and go to the higher performing, higher density core count, we'll call it processor options, you're not losing memory slots like we used to. And more importantly, we've even added more memory slots. So in those higher core count processor option kits, you end up with twice as much memory now in Synergy than we were able to deliver via Blade System. And of course, now we have an even broader set of applications that we can deliver via, well, basically more powerful computing, as I mentioned, with a lower cost per VM, which is huge, by the way. We're finally getting into and below the costs of per VM that AWS can deliver. And when you combine that with our low-cost shared direct attached storage and then the rack scale fabric, you're looking at much lower cost across the board in this solution set versus what anybody else can deliver. Our only limit here really is that shareable disks right now have a max of 71 can be mapped per server node or per compute node, as you were, and that's really limiting us. That's what limits us to being able to put 4 of these shared DAS storage drawers in any one frame. Now, that's really the only limit today, and I'm certain that that's going to change in the next few years. All right, Dan, well, as we go into the innovations that we've added in here via the Synergy Composer and the Synergy Image Streamer, I know you were really on a roll, and I had to cut you off because I knew we had this in detail here. So tell us what it is, really the full capabilities of the Composer and the Image Streamer and how they work together.
Sure, Joe. And I get excited about new technology. So,
and as do I. But you're younger, you get even more excited. I love it. Let's hear it.
So for the composer and the image streamer, you could think of these as, two guys working together to deliver the entire stateless compute environment. That is, the Synergy composer is responsible for the physical state of the server. It's going to be responsible for firmware settings, BIOS settings, LAN and SAN connections, all that good stuff. While the image streamer becomes a repository for our software settings. That is a house for all of our golden images, so that when it comes for that rapid deployment of that next server, that's where that boot volume is going to live. And that's what allows us to create boot volumes in under 15 seconds for rapid provisioning, right? Two very unique tools that enable the composable infrastructure.
Absolutely, and you'll see that we get into the FrameLink module, and one of the things that's so important about the FrameLink module is not only does it allow you to scale and do that rack scale across multiple frames, creating, we'll call it virtual chassis, right, within this Synergy infrastructure, but more importantly, it also holds the quorum disk, right, for our VSA cluster, which is what's residing and running in the image streamer. So the image streamer isn't just like a media library, it's actually a cluster of storage that allows us to do instantaneous snap copies of images and boot nearly instantly those nodes that are now going to boot off that particular image. So it has basically a set or a library of multiple images that are presented to you via one view, via a portal, right, a management portal, and then when you decide what image you want to boot, it snaps it off, maps it, and boots it within 15 seconds, which is amazing. And of course, you don't have to worry about losing one. There's two, plus the third quorum disk that resides in, or the quorum file that resides in the FrameLink module. All of them basically have multiple functions. So as we move on and look at this, we're going to get into now the frame management ring and how that works. So Dan, tell us a little bit about that.
So we changed the FrameLink module a little bit from C7000. Back there it was known as the onboard administrator. In this FrameLink module, we're creating a 10 gig Ethernet copper network that connects all of these frames, like you said earlier, Joe, into this larger logical frame or logical enclosure, if you will. And that allows us to make all those changes, right? If we're rapidly instantiating and tearing down instances of applications, we need to make sure we have an out-of-band network for that management plane that allows all of those changes to take place without impacting our data services. And because of the way we've done it, yep, go ahead, Joe.
Well, you just mentioned something that's really important, right? And the fact is that we have been able to maintain the management network as a separate out-of-band management network, basically air-gapped from the data networks, and even with the option of air-gapping that from the storage network, since we maintained native fiber channel storage within this environment as well. And that's really important for our folks to understand. All right, so then how are we delivering all of it, right? The accelerated delivery model, right? We get into that basically the composer is powered by HPE OneView 3.0, and we've put a lot in there. So Dan, tell us a little bit about what's in there and how does it reduce complexity?
Sure, Joe. So for some of the main features of 3.0, one thing, being able to manage that environment with just two composers, that's a big deal for us, right? So you're not spending your money on management servers, you can spend them on data servers, right, and application servers. Secondly, firmware and drivers. I can't tell you the number of times I've walked into a customer environment, asked them the last time they updated their firmware, and hear never, once, or twice, right?
And you know, hey, and once a year's fine, right? We still only mandate or desire, if you will, require one update a year in order to stay within support and be able to get directly to level 2 and level 3 tech support. So that's kind of important, and that's still a differentiator for us. But yeah, making those updates simple, and of course, if something messes up, God forbid, you know, we make it easy to even roll that back with an automated rollback feature.
Exactly,
so that's really
Joe.
important.
Took the words out of my mouth. And a differentiator for us in that space is also OneView will validate the way those firmware and drivers are laid down based on the operating system, so the frequency of us having to roll back is less than anyone else in the industry.
Right, and the scaling, when we say efficient scaling, I know we've mentioned it, but I want to mention it a couple times here. We're not just scaling to 1 or 2 or 3 frames, and of course the fact that we can in fact even start with 1 frame and support that in production, right, because we can put 2 composers in a single frame, still have that redundancy. Right now you're not going to have HA or high availability because you still have 1 frame, but the fact that we can do that for those ultra small SMB environments that still get all the benefits of complete composability with everything else built in, that's pretty important. And then being able to efficiently scale all the way out to 20 frames, that's pretty nice. So the question is, how do we do all that with the image streamer? What does it really do? So tell us about that, Dan.
Sure. So again, we mentioned earlier that the image streamer is that highly available clustered repository of those images, right? So we're able to easily migrate workloads, right? Let's say I have 1 frame running my VMware environment, I have another frame that just happens to not be doing anything, but I need to replace everything into a Hyper-V environment because I have a new CIO and he wants to go Hyper-V. I can easily do that now because I just create my Hyper-V template with my composer. My Windows Server image is sitting on my image streamer. I create that boot volume, and then I'm rapidly deploying those to whatever number of modules that need to be my Hyper-V servers. It gives me a fast, reliable way to do that.
Yeah, you can actually deploy multiple at a time, right? So Dan, let's talk a little bit more about the image stream. And I see we're going to dive in here, the difference between the profiles and the templates and really our view of stateless computing. So tell me a little bit more about that.
Sure. Stateless computing is the idea of that server has no idea what it's been or what it's going to be in the future, right? There's no information about its BIOS settings, firmware settings, anything like that. So when we go and deploy that new instance of whatever type application server, the composer is what's remembering the physical state of that server is going to be, and then the image streamer is responsible for the software state. And that's not just an OS deployment. That's going to go all the way up into a customized application. So instead of having to go down and crash cart server by server and then create those settings and reboot and reboot and reboot, let's just create that one time, make it a golden image, and then provision rapidly.
And you know what, this is really important, Dan, right? Because, how many other tools or utilities and or costs for licensing of, we'll call it workflow or orchestrators would be required from Cisco, right? If you looked at Cisco's UCS Manager, you'd need UCS Manager, UCS Central, UCS Director, and you'd still need some other orchestrator elements on top of that from their cloud infrastructure or their cloud automation utility in order to do everything that we're doing within OneView, within the image streamer and the composer here. And that's really important to understand. You get it all, and it's all built in. But the question is now, are we just talking about one type of compute module then, when we look at this stateless compute model, or do we have multiple to choose from, Dan?
We have multiple, like we saw in the image earlier. We have half heights, full heights, and then a unique full height double wide, which allows me to create up into a true 8-way blade, which is a very unique solution in the x86 space. So
do me a favor. Let's go one slide further here, and let's actually show them what they look like, right? So we can go from 8 cores to 96 cores. Just trying to set you up and keep us moving.
Gotcha.
All right, so now tell me about these. What makes these different, other than the half height versus full height and the single wide versus double wide? There's also some commonality here, right?
Commonality being, on one thing, right, from an I/O perspective, right, we're able to drive some serious bandwidth between all of these, right, with 3 distinct fabrics being able to be created, whether we're in a half height or in the up to the full height double wide, right? And that's really important when it comes to isolating those networks and creating predictable performance, right?
Well, exactly, and you know what, as I always say, I tell everybody, and apologize for being straightforward on this thing, but we at HPE, we're engineers. We design stuff, right, whether you spell that with an S or an SCH. And our problem is that our marketing messaging has this reverse airflow issue. instead of blowing the information out across the field and to everybody, we tend to suck it in, because our message sometimes tends to suck. But the bottom line is here, just to keep it light here, is we say storage from 7.6 terabytes to 15 terabytes. That's internal storage that comes with those units that can be placed within those nodes themselves. That's not including the localized storage that can be mapped to from those storage modules, right? And the bandwidth we're talking about here is current bandwidth, 3 times 20 gigabits per second or 60 gigabits per second, actually delivered in a non-blocking fabric, unlike the competitive offerings out there, right? All the way up to 10 times 20 gigabits or 200 gigabits of I/O to the 680. And the really neat thing about this, Dan, right, is that the 620 is mapped together with another 620, and you connect it via crossbar switch in the front that looks a whole lot like the old titanium crossbar switch that enables our superdomes in the old former blade system, and that's how you create a 680. A 680 is basically two 620s connected together. So that the commonality and the lower cost enables you to have a 2-node that you can quickly create or map into a 4-node. And that does take some physical mapping, as well as obviously you can then image it at will, right? So there's a lot of flexibility here and a lot of commonality of parts and components. And then when you get into the compute module options, as far as the localized storage, when we talk about 7.6 to 15 terabytes locally in the storage controller, the adapters or the mezzanine cards, the graphics cards and the NVIDIA M6 Tesla card that's available in the 480. So, a lot of the same options that were available today, but we also have the PCIe NVMe SSDs, the non-volatile memory capabilities, the smart array controllers that everyone's come to know and love, and of course the ability to have 2 drives per bay or 4 micro form factor, or MFF drives as we're calling them, or sorry, you'll see the micro FF as is pictured there on the bottom left of the leftmost quadrant there, the dual flash micro form factor drives. So that's really cool. Now what am I leaving out here, Dan?
Well, I would say the coolest thing of those dual flash micro form factor drives is now I can do RAID 5 on a half-height blade, right? I have the 4 drives. That's really nice, especially if we're not using those as the boot drives, since we're using something like Image Streamer, right? So that's a unique advantage. And then finally, right, I would add.
Plus with the port wine connectors, well, one can assume that these are hot plug, right?
That's right. So anything that's port wine is that beautiful port wine color we're all familiar with. That is a hot plugged device, whether it's a fan, whether it's a drive, and a hot plug device can be removed safely. So when properly pressed.
All right, and then when we get into the operating system options, there are many, right? From Linux to Open Linux, right, with Debian, CentOS. We got Fedora, SUSE options, and of course now SUSE, for those of you that aren't aware, SUSE of course is owned by Micro Focus, and with the spin merge that HPE just did with Micro Focus spinning out our cloud software division, we now own 50.1% of SUSE in return, which is interesting. But then, with virtualization, obviously the leaders there are VMware and Citrix, and of course Microsoft with Windows Server 2012. And we'll be adding in other operating systems continuously, as we always have in the life cycle of any ProLine server. And this is, in fact, these are ProLine servers within the Synergy family, right? Now, how do these redundant fabrics work? I know mapping in these triple fabrics, and it's 3 redundant fabrics, right? How does this really work, Dan? Tell us a little bit more about the A side, B side, and interconnect base.
So compared to C7000, this is a little bit of a departure of how we were doing it there. We're still in virtual connect land, right? And with Synergy, it allows us to create 3 distinct fabrics, right? And depending on what we're trying to do with the solution, whether we're using that SAS direct attached storage, trying to do converged storage and IP out of the master module. Let's say we want the fiber channel and the Ethernet coming out the same connections, or we need that true dedicated 16 gig fiber channel SAN. We can provide that, and we can architect to the appropriate solution so it matches the cost and the performance levels of your environment.
Well, and you know what, Dan, you are so smooth. It's almost as if you're reading a script, and yet I know you're not. So that's really impressive. So now tell me about these three redundant fabrics. I think one of the biggest differences is in the former blade system environment, with our half-height blades, we could only map to two of the three fabrics, and you had to have a full-height blade to map to that third fabric. So is that still the case here with Synergy?
No, that is not the case. Our half heights can have the full three fabrics in Synergy, which is a huge deal for us. Very flexible architecture.
It is indeed. It is indeed. So let's share some fun facts here. When we talk about these fabrics and the I/O, when we think about why did HPE go to all the trouble to go to this extreme growth in network fabric capability, right? So we're asking. You're going to find out that these fun facts actually come from our friends and family members from Cisco, right? So the question is really inside data centers, in what direction does the dominant volume of traffic flow in the data center? And of course, Dan, lay it on me. Which direction? It's east to west, right? And while Cisco may say that they've solved the east to west problem, in effect they really haven't, right? Because they're still delivering a 1.2 terabit midplane that is minimally overscribed in the fashion of 4x to 8x and sometimes even 16x oversubscribed, while we're delivering a zero non-blocking environment that's delivering, as I said, 15 terabits per second. So what percentage is it actually that's going east to west? Almost 80%. Now, we all know that 60% of all 80/20 statistics are made up on the spot. This is not one of those, right? So that leaves 17% going north-south, and inner data center traffic makes up that remaining 7% between the 93 there. The bottom line is that almost 80% of the traffic goes east to west, and in many other infrastructure environments, that requires that data to go from one compute node out of that shared chassis frame environment up to we'll call it the top of rack switch, and in some environments it even has to go one step further because you're actually not leaving the unified, we'll call it compute environment, if you will, right, until you leave that, the FI. Okay, for lack of anything else. Now the question is, how does our rack scale fabric work? Dan, so tell me a little bit about this. I know pictures go a long way here, and we've got a couple to share with them. So just step me through these.
Sure. So if you noticed in the image on the left, we have a master module and a satellite module. And what we do is as we start scaling that environment out, we can separate which frames have master modules, and in the corresponding remaining slots, put about the satellite modules, which cost about a third of the master module price, right? So as you scale the environment, we're, as you said earlier, Joe, helping you with the TCA and your TCO, right? And because of the way this structure works, this is what enables that east-west traffic flow that you were just mentioning. Now, if I have a master that wants to talk in frame 1 and wants to talk to frame 4, I just travel over this 120 gig pipe down into that satellite module.
You said 120 gig pipe. Oh my gosh. So, and what's the cost of this in relation to what we've been selling over the last few years?
In my opinion, it's dramatically more cost effective to scale a Synergy environment compared to a C7000 environment.
Right, so the bottom line is it's lower cost, and we're going to get into actually comparing the cost of scaling these fabrics versus a blade system fabric versus, say, a Cisco fabric. When as Dan mentioned, the satellite modules are 1/3 the cost of the master modules, and the master modules are lower cost than today's current virtual connect redundant fabric modules, right? So you had to buy two of them in the old environment. Now you just buy a master and a satellite, and you have that redundancy within each frame, or the left and right side, right? And then we're going from one master that has 120 gig links and allows you to map down to multiple satellite modules. So tell me about this, the 8 nanosecond for packet transit time or delay, interfabric with delay or interlink delay, and then also, how do these retimers work, and just how far does this scale across how many frames?
So what we do is we create something called logical enclosures, Joe, and depending on whether we're traveling at 10 gigs or 20 gigs in the downlinks down to my compute modules, that's going to determine how big this logical enclosure gets. It's usually going to be 3 frames for a 20 gig logical enclosure, 5 frames for a 10 gig logical enclosure, and that's sheerly because of those 120 gig ports that I was talking about before. And that satellite module is just a retimer, right? So when a command comes or a packet comes through that master and it needs to go from frame 1 to frame 3, it goes from master to satellite. All that satellite's doing is saying, hey, I've seen that packet. Let's give it a retime and make sure it's delivered appropriately.
That's really neat. Now, show me how this thing maps. As you're saying, you scale to either 3 or 5 frames, and it maps. You know, if you want to have 20 gig interconnect lengths, you can scale to 3, and then if you want to scale to 5, you're going to step down to 10 gig interconnect lengths. I think this picture really shows it very, very well. And yeah, so let's step me through this, Dan.
Sure. So I will just build that out one more time.
Sure, you got it. You built it too fast, yeah.
Yeah, exactly. So with the 10 gig modules, you'll see I'll start hanging these satellite modules off of the master module, one connection at a time. So that's a 12 by 10 gig connection for 120 gigs, and that's giving all of my half-height modules 10 gigs of bandwidth, right? So, and all hanging off of these master modules, and that's what creates that 5-frame logical enclosure for a 10 gig network. If I'm looking for the 20 gigs, we'll go to the right-hand side, and we'll see that that builds out just using 2 ports hanging down to the 20 gig satellite modules.
Nice. And of course, you know, it's really important to point out the cost savings is actually huge here, and I think we have we'll be getting into the cost savings here in the next few slides. Well, let's talk about those virtual storage pools, allowing you now to compose what looks and feels like multiple rack mount servers within this composable frame. How does that work, Dan?
So I think this is really a really interesting way to do direct attached storage, right? You got to think, what if I was doing this from a rack mount perspective, what would it look like? From an HPE perspective, I'd be putting a DL380 connecting over 12 gig SAS cables to something like a D3000 or maybe even a D6000 if I need, you know, lots and lots of storage, right? By putting those direct attached storage modules internal to the frame, we're not only saving rack space, but we're also allowing you to provision that from the same interface. And for someone who's scaling every time they have a new project, here's 2 more servers and another big JBOD that I got to put in my rack, that consumes a lot of space very fast. So this is a big advantage for those types of customers.
You're absolutely right, and more importantly, to your point earlier when we talked about the automation with VSA, you know, and coming down the line, obviously the automation with SimpliVity within this infrastructure as well, you know, being able to add VSA and have VSA automatically scripted to be installed on the fly, or you can map them as local drives and have what looks and feels like rack mount servers. So I have the benefits of a fully articulated or composable environment where I can compose individual what looks or feels like 1 or 2U or 4U 4-socket servers with the same or even more local storage than I could do in today's rack mount servers. And I can even automate them to be mapped out into clusters at a time with the entire application set. This is hugely flexible. And then when we get into all the other storage options, so tell me a little bit more about the rest of the Synergy storage portfolio.
Sure. So depending on what your application is, and we have different reference architectures and reference configurations based on those applications, you're going to use different types of storage. Different applications have different performance metrics, capacity metrics, and we'll use the appropriate type of storage for that, whether that's a local drive with that compute module from a SAS module to a flash, maybe even NVMe, or maybe no disks on the local compute modules. So we'll use that direct attached composable storage, right? Remember, we can fit up to 160 small form factor drives in one frame, right? So that's quite a large amount of storage. We could then create a software-defined storage pool with something like Store Virtual VSA and share that storage outside the frame over iSCSI. And then when we need that tier 1 performance, we can connect it to something like HPE 3PAR for the ultimate level of composability.
Very, very cool. And you know what? I know we only have about 12 minutes left, and we're going to be ending perfectly on time here. But what I wanted to mention here, as we're going through the last 8 or so slides, for those of you that may have questions out there on the line, I see we have about 30 people dialed in. You can type in questions in the question box at the bottom, and we can interactively or dynamically answer those either in real time, or we can type them in while one of us talks, the other one types. So please, feel free to ask those questions here in real time in that question box there in your tool. So let's talk about Synergy versus C-Class. I've talked about it several times. One of the real primary tenets that we wanted to do is when we were designing this and delivering this, and say one of the mandates was that we had to deliver this new infrastructure at roughly the same cost of blade system. And as you can see on the slide here, as we're comparing the compute, the networking, the rack, the software, the hardware support, software support, we're not hiding anything here. This is a list price comparison here, and by the way, we're able to have the same kind of pricing benefits that we've always had here as far as options goes. You're looking at this is really priced competitively. In fact, we've underpriced ourselves versus our current blade system while over delivering much more capability and much more scalability with Synergy. So the savings are instant. This is a lower TCA or total cost of acquisition. So then as we get into the next one, now we're talking about some other benefits now versus Cisco and Dell, because obviously Cisco's not delivering anything obviously that's future ready. They don't have photonics capability in there. They're still living on or dying on a 1.2 terabit per second midplane. It's not composable. In fact, and of course when you look at Dell and hear what Michael Dell is saying online, and I promise I'm not making this stuff up, Michael Dell was just quoted online from CRN as having said that HPE made up the term composability. We're the only ones talking about it. We're the only ones delivering it, and he's going to sit back and wait for this new technology to settle in the industry to figure out how it gets standardized and implemented, and at what time, whatever time it makes sense to jump in, that they can deliver the solution with the same cost benefits and the same cost, or a lower cost in the marketplace, then they'll do so. Well, bottom line is, and by the way, and as I said, they're delivering this new proprietary technology. Let me just remind everybody out there that smart technologies, self-monitoring, reporting technologies were in fact also posed as Michael Dell as proprietary from Compaq back in the 1994 timeframe. And let's just remember that also converged infrastructure was also claimed as proprietary by Michael Dell at one point in time, that Compaq and HP had brought out a proprietary technology that nobody else was doing. And of course, as we all know, everybody does self-monitoring reporting hard drives and self-monitoring reporting processors and memory and power supplies and fans. It's absolutely an industry standard and an industry expected technology in order for something to be defined as enterprise class. So let's move forward and talk about how this compares to Cisco and Dell. When we look at the Cisco comparison of Synergy versus Cisco blades, connecting in and adding in the frames, the interconnects, the others, the FIs from the UCS Cisco perspective, the hardware support, the software support, and of course the power cooling, everything else, we come in actually 15% lower than Cisco while delivering, well, let's just face it, almost 15 times more bandwidth. And Cisco's the networking company, not us. Well, or so they might say. We're obviously in networking, and we're delivering more fabric, more I/O, non-blocking capability, more expansion capability and growth for those applications that really demand it today at a much lower cost. And how do we compare versus Dell? So, Dan, tell us about how we stack up versus Dell.
Well, yeah, I think the chart says it all. I think we stack up very favorably, especially when you start, and regardless whether it's Dell or any rack mount, in my opinion, when you start going from a large rack mount environment into a consolidated bladed wire once type environment with HPE Synergy, you're going to see dramatic savings in the networking space, and as well as from the compute perspective with these very dense compute modules that we have relative to how much space that rack would be taking.
Absolutely, and that's a great point, right? The bottom line is, takes up less space, delivers more capability, more bandwidth, and even more internal storage capacity than you could do in any one rack mount. And that really says it all, being able to do more in that same space. And let me just answer one of the questions that was posed online here. before we wrap up, because the question is then where do we go from here, and then also we have some challenges and some questions for you, but before we go there, I want to talk to you about, the question was, can we host ERP systems from SAP and Oracle? And the question, or the answer is, of course, absolutely yes. Not only that, this is a great infrastructure for lowering the cost of licensing, because we can handle more cores, more memory, more I/O, so you can consolidate in here and not have to buy the same number of, we'll call it, nodes. Especially if any of that ERP infrastructure is virtualized, I can now host up to twice the number of VMs per node, thus radically reducing your ESX licensing. The same thing goes for Oracle. And in fact, we actually have a really great Oracle refresh or Oracle scale out alternative lower cost comparison example that I'd be glad to forward to Jeff that posed that question here. So I'll make sure, Dan, that we forward that, the answers to those out and the examples to everybody as we follow up here. But just to summarize, bottom line is that Synergy and our composable infrastructure allows you to run anything while reducing your CapEx as well as your OpEx. And of course, what we didn't talk about was our ability to deliver this via flex capacity. And that's our flex capacity acquisition, or services-based, we'll call it payment methodology, where you pay as you go versus paying as you grow with CapEx versus OpEx. You have the option, you can do either one, and this isn't to be confused with, of course, the flux capacitor 1.21 gigawatts, which, of course, as we all know today, we have many data centers out there, by the way, that we're delivering much more than 1.21 gigawatts. But this infrastructure, thankfully, doesn't require that kind of power, right? Because we're radically reducing that while working more efficiently, faster, and unlocking much more development value for your customers. So, the journey to composable infrastructure starts with bridging that composable, starting with partially composable infrastructure that your customers and you may already have today. Blade systems that are already managed by OneView, that already have the capability with our basically OneView 3.0 template and profile capabilities, being able to reside right next to or on top of a Synergy frame that can then be brought together and be monitored together via our OneView 3.0 global dashboard. We didn't talk about the global dashboard, but that's our OneView federator that allows you now to federate up to 20 OneView appliances. One of those OneView appliances would be each Synergy composer that can then scale up to 20 frames as well. So you've got the ability to handle up to 20 Synergy composers that can scale up to 20 frames each times 12 compute nodes, or mix and match those with any combination of OneView appliances managing DLs or Blade system today, plus another 20 hyperconverged appliance modules or clusters that can all be brought together and managed via our OneView federator, which is our global dashboard. So all this delivers basically faster time to return on investment and faster time to actionable insight for you, your business, and our customers, thus allowing them to deliver disruption to their marketplaces and to their competitors. And that's really what this is all about, adding in more business, because as we all know today, the idea economy is moving fast, it's changing fast, just like Ferris Bueller. Sometimes you have to stop and turn around, but bottom line is, with HPE Synergy, we're enabling you to move faster. So Dan, I think we have some learning checks and some a challenge for them here. So we ask you to complete the survey and earn tickets to the Phillies game that's on May 9th. Tell me a little bit about that, Dan.
So I think that's pretty self-explanatory, right? You should be receiving a link to the survey, right? Quantities are limited, so make sure you fill out the surveys.
Quantities limited. That's right.
Yeah, exactly, Joe. I will be there as well. I look forward to meeting some of you there, hopefully, and I believe that's where we're at. I think that's the end of our webinar.
That's fantastic. Now, I think, let me just make it sure we don't have any more questions here online. I think that was the only one. Are there any other questions online that I missed here? I think that's it. Well, with that, I know we're finished a couple minutes early, but I want to thank everyone. And Dan, thank you so much for keeping this light and keeping it interactive. I know there's a lot of new technologies, there's a lot of new buzzwords here, and of course we're never short on acronyms. When we come up short, we make some new ones. So thank you very much for playing along and sharing your time with us this morning. We're excited about Synergy, composable infrastructure, composable fabrics, and fluid resource pools, and we hope you are now too. Good luck and good selling. Thanks for dialing in today.
Thank you, Joe.